Okay, in this video I'd like to discuss really big numbers, okay? And I think this is important because there are questions in the Applied Maths course which deal with really big numbers, and sometimes you can get lost in them and you can be keeping detail which has become irrelevant. So I'd like to first of all discuss scientific notation. The number 1 million is in our life a big number. Okay, because we're not used to dealing with a million. However, if you're dealing with maths, science, or engineering, for example, 1 million is a small number. You'd be used to dealing with numbers, trillions, billions, billions and billions. So a million is really not a big number. And for that reason, it's often best to be able to shorten these down. You want to be able to write shorthand. And what we use is the power of 10. Remember, each of these zeros is a 10, so that's 10, 100, 1000, 10,000, 100,000, and then we finally become to a million. Alright? So we would write this number as 1 times 10 to the, and we have how many powers of 10? We have 1, 2, 3, 4, 5, 6. 6 powers of 10. So 1 times 10 to the 6 is equal to 1 million. Alright? What if we had a number 89743210? How would we write this particular number in scientific notation? And how big is it? Well, the answer is very simple. You take the first digit 8 and the second digit, which is 9, and you'd write it 8.9. You'd multiply it by 10, and you'd now see how many powers of 10 you require. 1, 2, 3, 4, 5, 6, 7. So this is 8.9 times 10 to the 7, or approximately 9 times 10 to the 7. Okay, now how much bigger is this number than a million? We know that 1 million is equal to 1 times 10 to the 6. So first of all, look at the power of 10. We have one difference in the power of 10, so it's at least 10 times bigger. At least 10 times bigger, and that's not taking into account this 9. So this 9 is actually close to, we'll say, 10, so it's almost 100 times bigger. It's close to being 100 times bigger, yet there's only one digit, we'll say, in the power of 10. But the power of 10 is a big number. So how about, what if you had a number like this? What if you had 10 to the 21 and 10 to the 8? What if I wanted to add the two numbers, 10 to the 21 plus 10 to the 8? Okay? Now, first of all, how much bigger is the number 10 to the 21 versus 10 to the 8? And you might say, well, it's actually 13 times bigger. And the answer is, you are absolutely incorrect. Remember, we are talking about powers of 10. So it is 1 with 13 zeros bigger than this number here. It's bigger than 10 to the 8 by a number bigger than 10 to the 8. Alright? So the point I'm trying to make is 10 to the 21 is ridiculously big in comparison with 10 to the 8. Okay? One more comparison I'd like to make is, if you had 1 million euros and I told you I was taking 1 cent from your million euros, you would still say you have 1 million euros, because you have 1 million euros and each euro is worth 100 cent. So this is actually, you actually have 1, 2, 3, 4, 5, 6, 7, 8 cent. So you have 10 to the 8 cent, and I want to take away 1 times 10 to the 0. So you're taking 10 to the 8 minus 1 times 10 to the 0. It's, what number is that? That is 100 million. So you're taking 1 cent from 100 billion. So you're going to say you still have 100 million. There is almost no point in starting to put in the nines because the numbers are so big in comparison. Alright? So let's look at one more. The amount of atoms in the universe, I think, is on the order of 10 to the 74. Now, I may be incorrect, and it might be 10 to the 72, which is 100 times bigger or smaller, but we'll say it's 10 to the 74. And if I was to say to you that the human body, I can't actually have no idea, but we'll say it's 10, I think it's 10 to the 48, but I'm very much open to correction. So there are this many atoms in you, and this is the amount of atoms in the universe. And you might say, hold up a second, 10 to the 48 is very close to 10 to the 74. Surely that can't be right. And then I would say to you, absolutely not. So if you were to take 48 from 74, 74 minus 48, you get 26 zeros. One with 1, 2, 3, 4, 5, 6, dot dot dot, until you have 26 zeros. That's how many times bigger this number is than this number. So you'd say, well, 10 to the 48 atoms may seem reasonable. And the last thing I'd like to show you is, if you're taking away big numbers, say if I wanted to take away 4.316 times 10 to the 21, I wanted to take from that 3.9246 times 10 to the 3. Now first of all, we realize that we are 18 powers of 10 in the difference. 18 powers of 10. So we are billions of billions of billions bigger, or trillions of trillions of trillions bigger. Okay? But what if we were to plug it into the calculator? What would happen if we did this? 4.316 times 10 to the 21 minus 3.9246 times 10 to the 3 gives an answer of 4.316 times 10 to the 21. And you might say, hold up a second, but we took 3 zeros. What's that? We took nearly 4,000 away from it. But the point is that this number is so much bigger that it's the same as taking nothing from it. Alright? So big numbers are just big. If there's a big power of 10 in the difference, well then you could quite easily do the following. You could say, let me write that again, so what was it? 3.9246. Okay? You could say the following. You could equate this to 0, because it is so small in comparison that it may as well be 0. So I think this is quite important. It's quite intriguing as well. So thanks for watching. Please pass it on to your friends and subscribe to my channel.